All right, here's a triangle right here. We're going to learn another word. Just as a real quick recap, we've learned a couple words already in the last lesson or so. Well, it's actually only one lesson, but we kind of broke it up into two. What was the first thing? We took a side of a triangle and we did what to it? Found the
circumcenter.
Yeah, but to the side. What did we do to the side though to get the circumcenter? Perpendicular bisector. Right. We did the perpendicular bisector. If we did the perpendicular bisector of all three sides, look, if I bisected this, perpendicular, bisected this, perpendicular, bisected this, perpendicular, they all met at one point. We called that the circumcenter. Then the next lesson was we took the angle and we did what to the angle? Bisected the angle, okay? So we bisected all three angles. They met somewhere inside here, right? And we called that point the incenter. All right. And something was true about the circumcenter too. Let's say the circumcenter was right here. What was true about the circumcenter? The circumcenter was the, well, no, we've never said it's the middle. What did it do?
Oh, the center of that.
Nah, it's not. No, that was something else. What was true about that point? That point was equidistant from the vertices. That's right. Listen. So wherever the circumcenter was, it was equidistant from the three vertices. You with me?
I thought that was the incenter.
No, that was the circumcenter. The incenter, though, right? How did we find the incenter? We bisected all three angles. Bisected all three angles. It's somewhere around in here. What was true about that? It was equidistant from the... Yeah, well, it's equidistant from the sides of the triangle, right? Now, within the word of equidistant means it's the distance from a point to a line, which means it's perpendicular, okay? So when we say equidistant, that's kind of assumed that it's perpendicular. So it's perpendicular or it's equidistant, the same distance from all three sides. That's the what? What word is that one again? When it's perpendicular or when it's the equidistant from the sides of the triangle, that's the incenter. That's right. It's the incenter. You got it? Okay. Now we're going to learn a third one today. Actually, we're going to learn two today, but the third one probably has a lot more meaning than what the fourth one does. And here's the word. It's median. We talked about this briefly yesterday. We didn't record it, but we talked about it. We said the median. Remember, you're driving down the road and you got that grassy area between the lanes of the road. What do you call that? The what? Median. Why? Because it's in the middle. It's in the middle of the road. So what we're going to do is, yeah, let's just draw all three medians. The median is this. You watching? The median is from a vertex. Some people look at this and they say, well, this kind of looks like angle bisector, but it's not necessarily an angle bisector. It is from the vertex. I'm not looking to try to bisect this angle. What I'm doing, I'm starting at the vertex, and I want to try to hit the opposite side right at the midpoint. Okay, help me out. Where do you think the midpoint is? To the left, to the left? Right there? Okay, yeah, on this one I actually could click it and see. Yeah, it's right there. Good call. All right, so let's do this one now. Let's start here and go to the midpoint of the opposite side here. So where's that going to be? Around here somewhere?
I think so.
Maybe, I don't know, right there?
Yeah.
You sure? Okay. All right, let's see. It's probably, yeah, it's probably the line that goes right in between there. So yeah, that looks like it. Let's make that red. Okay. All right. And then let's go from here. Now guess what? In both of those examples we talked about before with circumcenter and incenter, all three lines intersected at one single point, didn't they? So that means those lines were what?
Congruent.
No, not congruent. It's close to congruent. Concurrent, right. Those lines were concurrent. Well, these are also going to be concurrent. So look, if I tried to hit the midpoint of the opposite side here, guess where all three lines are going to hit?
The middle.
Right. Well, we don't really say middle, but they are concurrent lines, okay? At the point of concurrency, right, that's good. At the point of concurrency. But this point of concurrency has a special name. Just like the circumcenter had its own name, the incenter had its own name, this has its own name as well. And we call that the centroid. All right? That's funny. The other class did the same thing. Somebody in the other class did the same thing. They said centroid with a droid, sounded like that commercial with the droid thing. Anyway, so yes, so that's the centroid. All right, let's just call this ABC.
A, B, C.
I'll call this JKL. That's JKL. Alright, what's cool about this? Now watch. It's cool enough that they intersect in one point, okay? To me, that's kind of neat. Alright, if you do all three of those, look, if you find the perpendicular bisector of the sides, they all intersect in one common point. I think that's interesting, don't you? I think if you took the angle bisectors to all three angles, what happens? They all meet at a common point, right? If you take the median, which means you go from the vertex to the midpoint of the opposite side, what do? They all meet at a common point. I think that's kind of cool. But what's even cooler about this is this. Watch this. Hopefully we were accurate on this. In the last class, we were very accurate. I couldn't believe how accurate we were on it. But watch. There's something about, we'll call this P for point. Okay, we'll call this point P right here. Now watch this. This is pretty cool. Now, do you think AP and PK are equal to each other in length? Nah, that's quite a bit shorter than this. In fact, this right here, AP is longer than PK. Well, it's not just a little bit longer. It's actually double. It's actually double this PK right here. So for instance, if this was 8, if AP was 8, what's PK going to be? It's going to be 4. What's the whole thing, AK? It's going to be 12, all right? But before we get into that too much, let's do this. I did this in the last class. Let's see if it works this time. All right, and I'll go blue, and I'll make this a little bit thicker, make it 2 points. Okay, watch this. If I'm just going to trace from P to K. All right, so that's the length from P to K. I'm going to copy and paste it. And let's see. Now, if I'm right, if I'm accurate on this, what should happen?
You should be able to fit 2 of them back.
I should be able to fit 2 of them. Okay, so there's 1, right? And let's copy and paste that and put another one. Actually, let's get this out of the way. Okay. Yeah. Boom, right there. It's pretty close. Okay, it's not quite exact, but that blue one was... Anyway, you get the idea, though. So 2 of those blue ones actually fit on here, don't they? All right, so this side right here is twice as big as this. Now, if you look at what the book says, they write it a little bit different. I kind of like to think of it as this shorter side. Let's say this longer side, AP, from the vertex to the point, okay? That's the longer side. That's twice as big as the shorter side. I think that's an easy way to say it. Here's how they say it in the book. They compare the longer side to the whole entire thing. They don't compare the longer side to the shorter side. They compare it to the whole entire thing. So they say that AP is equal to, what do you think? How much of the whole entire thing, AK? That's right, it's 2/3. If this is 2/3 of the whole thing, then this has got to be what?
1/3.
1/3 of the whole thing. Does that make sense? So AP is 2/3 of the whole thing, which is AK. That works for all the other medians as well. Right? I just chose this one, but it works for all the other medians as well. So AP is 2/3 of AK. You could think of it another way. You could say that PK, we already answered this, but let's write it down. PK is how much of AK? It's half? No. Of AK. PK, this one right here, the short one, is how much of the whole thing? It's 1/3 of it. That's right. 1/3 of it. Everybody see that? It all depends on your comparisons. Let's compare AP. I'm sorry, let's do this. Let's compare PK.
PK.
No, let's do it the way I was going to do it. Okay, AP is how much of PK? No. AP, this one, is how much times this one. It's twice. Everybody see that? Okay. And we could do it the other way, couldn't we? We could say that PK is what? Half of AP. Make sense? Yeah.
And on an equilateral triangle, that let PK, if this triangle was equilateral, say PK would be equal to PL and PJ, correct?
Yeah, all the medians would be equal to each other if it was equilateral, correct.
But this is scaling, so
but this is, right, we don't know that it's equilateral, correct.
All
right, does that make sense? So now you can see what kind of questions they're going to ask. It's not going to be real difficult, but I already did one before. Let's do another one. Let's say that was 3, PK was 3, and I asked you to find AP and AK. Well, AP is the easiest one to find. What would AP be equal to? 6, because it's just double this. And what's the whole thing? 9. It's 9, so AK would be 9. That's pretty simple stuff, isn't it? it's easy once you recognize the relationship between them, but if I didn't know the relationship between them, there'd be no way to figure that out, would there? All right, so it's nice that we know that. Let's do another one. What if we said, watch this. What if we said AK, this whole entire AK was, I don't know, 27, let's say. All right, and I asked you to find PK and AP.
18.
All right, so you could go 2/3 of 27, or what I think is easiest is to find the short side. So you'd go 1/3, or divide by what? 3, right? So 27 divided by 3 is 9. Since I know the short one, what's the longer one? 18. Okay? Does that make sense?
Your shirt matches your eyes.
Thanks. Glad you noticed. All right. Are we okay with that before I get rid of that stuff?
Yeah.
All right.
Body.
Let's. It's kind of this. Yeah. It's some of the things that they could ask you. All right. Let's take this a step further. Actually.
Let's go. Let's live on the edge again.
No. Let's do the next thing. Okay. I talked about median and centroid. Let's talk about one more of these deals. All right. Here's another word that we're going to talk about, and we may have talked about this word at some point before, but it's called altitude. Did we say altitude yesterday? Well, I said we were going to talk about it, but I didn't really say what it was. Now, we have talked about this. Watch. If I have, here's the ground right here, and you got a cool airplane. There's my cool airplane.
Wow.
That looks like a dive bombing.
That's cool.
Dive.
Looks like, look, looks like that. Looks like that bomber up there on my flag.
Looks like
Isn't that
a
cool?
transformer.
This is just a side view of that bomber. Okay, hush. Let's listen. Remember, we've talked about this before. If you're in a plane, the pilot, they always love to talk to you, right? Well, I don't know if they like it or not, but they do. They talk to you and they say, hey, how's everybody doing? What's up? And then they, I don't think they say that.
That'd be awesome.
Listen, shh.
Make sure your seatbelts are fastened.
Listen to me. Listen, come on. I don't want to take this long on this little simple story. You get on the airplane and they'll tell you, yeah, fasten your seatbelt. Well, the girls usually do that kind of thing, though, don't they? But they'll say, make sure your seatbelts are fastened. The weather is going to be, sunny and 80 where we're going to go and blah, blah, blah. And it's going to take us this long to get there. But one of the most important things they tell you, well, I think was an important thing they tell you, is how high that you're flying, right? And he says, oh, we'll be cruising at an altitude of 20,000 feet. Right? You can barely hear what they're saying, and they all mumble. I care. All right? I like to know how high I am. So if I fall, then I can tell people, well, I fell from this height. Well, I'm being very optimistic,
You can tell the people in heaven.
That's right. Yeah, 20,000 feet did me in. All right, so anyway, you're at 20 or 30. Listen to me now. You're at 20,000 or 30,000 feet. But what do they say? They say our what? Our altitude is 20,000 feet. So where is the altitude measured from? From the plane where? To where you're going to end up? Where is it going to be where you started? No, where? Perpendicular to the ground. So when we talk about altitude, we're really talking about the height, aren't we? Talking about the height of the airplane. Listen to me, please. So we're talking about the height of the airplane. That's the altitude. Everybody got that? So when we do, so it's from a point right here to a line. Okay, we just consider the ground being horizontal. Okay, just like that. But watch this. Let's go different color again. If I want to draw the altitudes to this triangle, I start at any vertex. I'm going to do it to all 3 vertex, and I have to drop a perpendicular from that vertex to the other side. So I'm not necessarily, no, it's not a perpendicular bisector, because I'm not bisecting. Because look, if I bisected it, would that even look perpendicular? No. All I'm doing is I'm starting where? From a vertex. When we did perpendicular bisector, we started down here at the bisector and just went straight up. Remember that? So we're starting right here, and we go perpendicular, which would be down just like this. Everybody with me? So let's do all 3 of them. Now that one I can do because I knew that was horizontal. I hit the shift key, and that makes it go straight up and down. Okay, David, you getting all this? Somebody tap him. I don't want him to miss out on everything that's going on. Okay. You're lucky I didn't pull my camera out. I'll take a picture of you. Okay. So there we go. That looks pretty perpendicular, doesn't it? Oh, I sure do. Let's do one more. Thanks for reminding me. Watch. Go perpendicular. Look what they do.
Oh, the altitude.
All right. They hit right there. We call that an orthocenter. Write it down. I don't have enough time. Ortho, O-R-T-H-O, center.
Bye, guys. Bye.